Okay, you got 3 examples. You need a scratch sheet of paper, and you want to write these down. This is your assignment for today. We're going to do 3 examples, and you got an assignment. This is the last of the content that we're required to cover for our standards. The systems of higher degree equations. So for example, a system is 2 or more equations. Often you guys are used to finding the intersection between 2 lines by using systems. That's pretty boring after a while because there's not really much to do. In fact, when you guys took that test last year in Miss Nelson's class, you guys probably all got 100%. It was you guys ended up doing what do they call it? Linear programming after that. A lot of matrices. That's good stuff. But what we want to do is we want to look at some higher degree equations. So let's say that we have a line and we have a parabola. How do we handle that type of situation? And the fact of the matter is that when we get to second semester, we're going to start out by looking at conic sections. And conic sections include circles, parabolas, ellipses, hyperbolas, all sorts of pieces. And that's normally where they put this section. Riverland asks that instead of covering it during college algebra, instead of covering it during trigonometry, you cover it during college algebra. Fine. So we got this one day we stick in here and quick do it. And you guys know how to do the same way. We'll spend time in the second semester, but I'm supposed to do it before you guys leave. Before you guys have a week off. What is the latest that some people will sleep? 2? Danny, 2 in the afternoon? Megan Boss is going to sleep continuously for days. Well, I hope you guys have a great break. While you're having that break, you're going to work on some of this. Still, raise your hand if you've ever watched one of my videos on YouTube. Okay, that's a lot of you guys. There were still some people first hour. They said that they could use a little bit extra help. I know that some people second semester last year, every night that they would go home and do their homework, they would press play on YouTube, and while they're doing their homework, they would just have the video on in the background to help them through it. Now, a lot of this stuff is still pretty familiar to you guys. A lot of things in second semester will sound like a new language. That's just the nature of the course with trigonometry. Let's graph these and see if we can tell how many intersection points there are, and then actually try to find them. So the first graph, x plus y equals 2, what does that graph look like? See how much you remember. You should be able to leave pre-calculus knowing what every graph looks like. What does that graph look like? X plus y equals 2. It's a line. Tell me something more about it. Slope of -1. Y-intercept, +2. I put it in slope-intercept form. Okay, y equals -x plus 2. I got to be able to graph that. Okay, that should be Algebra Basics 101. Okay, got to know how to do that. You will definitely do this a lot in calculus. You get to chapter 6 in calculus, you're going to do this all day. In fact, I'm going to have to review it with my calculus class this year. Yep. Okay, so we draw that line. There you go. That's the line. What does the second graph look like? Parabola centered at direction up. I draw that. How many intersection points does this appear to have? It appears to have 2. We need to confirm that algebraically. And we can do that through substitution. You can also use elimination and other methods. What I'm going to do is I'm going to do substitution. Now, you could solve for x and insert x here and square it, or you could solve for y and put y in right there. What do you want to do? Solve for y or solve for x? Let's solve for y. It's solved for. It's right there. I'm going to take that and put it in for right there. My new equation reads -x plus 2 equals x squared. What to do, what to do, what to do. Factor it. Thank you. 0 equals x squared plus x minus 2. Set it equal to 0. Anytime you have a higher degree equation, you're going to look towards setting it equal to 0, so we can use the 0 product property. This does factor. 0 equals x times x. What multiplies -2 adds to 1. +2, -1. What are my solutions? 1 and -2. Are those the x values or the y values? Those are the x values. We just solved for x. So if you look, this intersection point right there occurs at an x value of 1. This intersection point right there occurs at an x value of 2. Now what we need is the y values. How will we figure out the y values? Do you plug it into the parabola or the line? Doesn't matter. It's shared for each one. You can plug it into either. I'm going to plug in the parabola. 2 squared is 4. 1 squared is 1. Those are my intersection points. Piece of cake, upside down. See, Casey? I take a point off for your attitude and all of a sudden you're nice today. Ooh. That's smack talk. Any questions on the first one? Easy? All right, let's try something more difficult. Look at the next problem. Example 2, y equals x squared minus 9 and x squared plus y squared equals 4. As you guys are writing, note that it is my daughter's 8th birthday today. I didn't get her anything. Her mom will kind of take ownership of that right now. I did tell my wife what I think we should get her, and I think she went out and got that, but I'm not sure. Well, she really wanted this game where it's 10 games in one. She's really into like strategy games right now, like checkers, chess, Chinese checkers, Mancala, like all those different games. And so there's this game board that she wants that has all that. But I'm not sure. She also wants a bunch of fishing tackle, which we might get her. She wants to go fishing this summer. All right. Yeah. Oh boy, hold on. A for the day. Who knows what the first one looks like? It is a parabola. Tell me something about the parabola. Good. Shifted down 9 units. So I go -5, go -10. Shifted down 9. Aaron Murtaugh from first hour knew where this crossed the x-axis. Very impressive. 3 and -3. Very good, Mallory. See, Regent, I told you sat next to a smart person. So what she did is she set this equal to 0 and then factored it. She found that it crosses at 3 and -3. So that's my parabola, okay? You don't have to do that when you draw it, but it might help us. Again, drawing the graph is not... you don't have to do it in order to solve these, but it does help you to know what you're looking for. Now, x squared plus y squared equals 4. We'll see who's really smart today. What shape is that? Starts with a C. Circle. It's a circle. It's centered at 0, 0. Anybody know what the radius is? 2. The square root of 4, which is 2. Very good. Excellent. So what I'm going to do is I'm going to draw a circle centered at 0, 0 with a radius of 2. How many intersection points do you think there are? Doesn't look like there's any. Confirm that algebraically. Let's confirm that algebraically. Now, here's a decision that you have to make, and there is a better choice here. Would you like to take y and plug it in for y squared and square it all out, or would you like to solve for x squared and plug it in here? Let's solve for x squared. So you have x squared is equal to y plus 9, correct? So So let's plug that y plus 9 in for x squared. I get y plus 9 plus y squared is equal to 4. How do we solve that? Factor. First we'll go y squared plus y plus 5 is equal to 0. It doesn't factor. What do I do now? Quadratic formula, which is awesome, and it's quick. Negative b plus or minus square root of b squared minus 4ac divided by 2a. Look at how easy that was. Underneath the discriminant, underneath the square root is the discriminant. The discriminant tells us the nature of the solutions. Tell me, what value do you get underneath the square root? Negative 19. Can you take the square root of a negative? Therefore, how many solutions do you have? 0 real. How many imaginary? 2. So there's no real number that satisfies this equation. So we've just shown that we have an imaginary number underneath there. It would reduce to negative 1 plus or minus I square roots of 19 over 2. So therefore, we have no solution as far as the intersection points in the solution to the system. Okay? And our graph ahead of time kind of confirmed that for us. We understood that that was going to be the result. Any questions? Okay, the last one. Example 3. Oh, so yeah, I didn't really get my daughter anything. I think that my wife picked it up. But anyway, no, I'm in charge of the meal tonight. So, well, I do the cooking. Okay, there's your assignment. There's 11 problems up there. You could go ahead and just choose 8 of them. If you want to do all 11, that's fine. But, you know, there will be no extra credit. Your extra credit is that you get a 90% for an A- and a 3% extra credit for doing your study guide. So, that's a pretty good deal. No other extra credit. All right, there we go.